This is the presentation of Kyoto-U+ECNU participation to WAT 2020. The title is Meta Ensemble for Japanese-Chinese Neural Machine Translation. I am Joyan Mao, and this work is jointly done by Kyoto University and East China Normal University. First, an introduction to SBAC-JC dataset. Here is an overview of this dataset. First, we do the pre-processing. We tokenize Chinese by Stanford parser and we tokenize Japanese by Jomon. The valid in our experiments is merged from the original dev and dev test sets. And then the experimental settings. The vocabulary size is set to 40,000 and on the basis of 30,000 BP merge operations. We use transformer big as the basic model structure, and for the optimization, we use the Adam optimizer with the label smoothing of 0.1. For the decoding, we use the beam size of 12 and the length penalty of 1.6. The batch size is set to 2048 tokens. And we let the model share the parameters of encoder embedding layer, decoder input, and output embedding layers. And here are our systems. We revisit data augmentation by using out-of-domain parallel data and back translation. And we also try deeper transformer structures, deeper encoder plus shallow decoder framework, and also various sequence-to-sequence frameworks. Moreover, we also try the specific trick of character mapping on Japanese to Chinese translation, and we also try the recent very popular pre-training method called MBART. Finally, we implement a meta ensemble to combine different systems. So first, we tried data augmentation by using out-of-domain parallel data. Here are the out-of-domain parallel data sets, which are collected by the IWSRT, and we use all of the parallel data in this red box. So this results in about 2 million out-of-domain parallel data. Then we try to do the filtering. We filter 2 million out-of-domain parallel data by laser. Specifically, we use the laser encoder to encode sentences into sentence embeddings, and then we calculate the cosine similarity between sentence pairs. By the calculated sentence similarity, we can do the filtering. So in this table, we can see that if the similarity is over 0.6, the alignment quality is very good. So we set 0.6 as the filtering threshold, and sentence pairs whose laser similarity is smaller than 0.6 are removed. And after such filtering, 370,000 sentence pairs are filtered out. Then we also tried domain adaptation by using the domain tag in front of every source sentence. This tag has been proved effective by Chu in LSTM. This time we tried this out in the transformer framework. Then we try to do the data augmentation by back translation. We use Japanese sentences from SBAC-JE as Japanese monolingual data. There are about 3 million sentences. For the translation direction from Chinese to Japanese, we use the reversed model to back translate Japanese monolingual data. It is a very typical back translation. And for another direction, we also use the Japanese to Chinese model to forward translate Japanese monolingual data. So we call it forward translation. Also, we tried deeper encoder shallow decoder framework proposed recently. which is the encoder layer of transformer big is set to 12 and only with one decoder layer. Also, we try deeper transformer structures. Here is the standard setting of the transformer big model, and we modify the layers to 9, and we also tried the 2 times of the feed-forward hidden side. And also we tried various sequence-to-sequence frameworks, including LSTM, convolutional sequence-to-sequence framework, transformer framework, light convolutional framework. Then we tried a specific trick on Japanese-Chinese translation called character mapping. This trick has been proved effective in sequence-to-sequence pre-training and in the supervised learning this year. Specifically, we try to modify the Japanese source sentences by modifying Japanese characters into Chinese characters in advance. And for the Chinese source sentences, we modify the Chinese characters into Japanese characters in advance. For the character mapping, we use the character mapping table constructed by Chu. And also, we revisit the recent popular pre-training method called MBART. We fine-tune on aspect JC by pre-train MBART 25 model. Then here are all of the results of respective system. So in this table, we can see that systems of back translation by using transformer and light convolution framework achieved highest blue results. And although results of other systems are relatively low, but they do benefit the ensemble phase. Finally, we do the meta-ensemble. In our systems, there are mainly 3 kinds of the systems. First, different structures. Second, different training data. And third, different model setting. We do not consider MBART 25 and character mapping in our meta-ensemble due to their very different vocabulary and source sentence. Here are the results of the ensembled models. We do the model ensemble in a greedy manner, and only positive results are listed here. We rank first on both 2 translation directions on aspect JC task, and the number 25 and numbers 26 are the systems that we submitted to for the official evaluation. We will compare this meta-ensemble of different systems with the common ensemble in the future. Finally, the conclusion. We revisited several strong NMT baselines, tricks for handling training set, and also pre-training fine-tuning methods for Japanese-Chinese NMT. We found that most baseline methods can generate translations with different styles which can benefit the model ensemble. We conducted a search of better ensembled models and obtained state-of-the-art translation results on aspect JC task. Okay, thanks for listening.